Hello everyone. Welcome to session of wireless communication and networks. Okay, today topic is trunking and grid of service. Myself, Mr. A. Karthik, Assistant Professor, Department of Electronics and Communication Engineering. Today, mainly we discuss about the trunking and grid of service. In the previous class, we discussed about the frequency use and also handoff techniques. Okay, coming to meanwhile, we are using the trunking and also grid of service. Before that, we have to see the what is the outcome for this topic. Okay, whenever you learn this topic, we can give the channel capacity and also channel interference of the communication system of the. With the use of this one, we can improve in the design parameters. Okay, that's why we can choose this trunking and grid of service. Okay, first of all, what is the trunking and also what is the grid of service? Coming to any uh, communication system or any parameter, we can find out the some quantity. Okay, for that we are using this trunking and also grid of service. Okay, with the use of this, we can quantity the communication system. Coming to here, cellular radio system rely on trunking and accommodate the large number of users in a limited radio spectrum. Okay, for example, we are having this is a bandwidth. Okay, in this bandwidth, we can use the large number of users. Okay, we can allocate the large number of users. Okay, for example, we are in the one particular geographical area, there we having the less capacity. Okay, that we are fixed with some radio frequency, but users are very less. Okay, then we can use the same frequency and also we can accommodate the large number of users in that particular spectrum. Okay, this concept of trunking, it allows the large number of users, okay, that share the same information to the small number of channels. Okay, what is a channel? In the previous class, we discussed mainly about the channel. Okay, in the for example, we are having the channel 1 and 2, 3, 4. For example, here I taken 4 channels. Okay, if the all channels are occupied with the users, then what will happen? The call cannot be connected or any communication error will come. Okay, if it is this particular channel free only, then only we can accommodate the particular service. Okay, coming to we know the channel assignment strategies also in the previous session. In the channel assignment strategies, we are using the fixed channel assignment strategy and also dynamic channel assignment strategies. Both we are used. Okay, which one is burdened to the MSc, which one is not burdened to the MSc also we discussed. Okay, in this we can use this small number of channels with a large number of users. Okay, we can use the small number of channels and also we can accommodate the large number of users. Based on the demand, from a pool of available channel. Okay, in a trunked radio system, each user allocated a channel per call basis. Okay, for example, that is in the queuing system. If you are using the queuing system or also guard channel concept, okay, who's first come to, then they will take first serve. Okay, like that we are using the one call per basis upon the termination of the particular call. If the all channels are busy, okay, I am trying to call this one particular my friend, then all channels are busy, but after that one more person also trying to call. Okay, and the first person is the second person, then what will happen? They, whenever which channel is free, then accommodate first me only. Okay, because that is in the demanding of the particular access channel. Okay, that after this person terminated a call, then I can connect it to the particular service. After that, they will connect it to the second person. Okay, like that the given in the trunked radio system. Okay, this is the trunking of the particular system. Okay, coming to here, the trunking, it explores the statistical behavior of users that a fixed number of channels or circuits may accommodate the large number of randoms user community. Okay, the telephone company uses trunking theory to determine the number of telephone circuits, and whenever we can use this particular trunking system, we can also accommodate the office buildings with the hundreds of telephones. Okay, the same principle used to designing the cellular radio system. Okay, the same thing they can use for the designing the cellular radio system also with the help of the trunking of the radio service. Okay, you can see next one. The first one is the trunking. The second one is the grade of service. Okay, coming to trunking, what is the need of trunking? We can go with a small number of channels. We can accommodate the large number of users. You can remember that part. Then coming to grade of service, it is a measure of ability to user access a trunked system during the busiest hour. How you say the busiest hour? Okay, for example, in a one day, in the one day we are having the 24 hours. Okay, in a one day we are having the 24 hours from 0 to 6, morning 6, again afternoon 12, evening 6, and night 12. Okay, this is a one day busiest time. We can see, for example, in the morning session we are having the less number of traffic. Okay, again it started high number of traffic. In the medium, in the afternoon also less, and the evening high. Like that we are having the graph. Okay, if it is which one is the busiest hour, this one is the busiest hour, because whenever the traffic is high, okay, the based on the average call per hour, whenever the busiest hour is that, when the traffic is high, that is we can call the busiest hour. Coming to here, we can see the one example. The busiest hour is based upon the customer demand, that the busiest hour during your week, or also month, or also year. We can find out the individually. If we go for the one day, we can see the which time is busiest hour. We can take the average calls in a particular hour, then we can say that that is the busiest hour. If you go for a month, we can calculate the 30 days average time, then we can go with the month busiest hour. Like that also we can find out the year also. For example, the busy hours of cellular radio system capacity occur during the rush hours between the 4 p.m. to 6 p.m. on Thursday or Friday evening. Okay, this is all taken from the some researcher. Okay, this is the scenario we can find out the grade of service. Okay, mainly the grade of service is the ability to user to access a trunked system during the busiest hour. Coming to trunking, what is a trunking means? We can accommodate the large number of users in a small number of channels. Okay, these 2 points you can remember. Then the based on these 2 points, we have some problems that also we can see in this session. Coming to traffic intensity, how we can find out the traffic intensity? We know the traffic. In a general way, what is the traffic? The vehicles are gathered in the one place, that is called traffic. Like that in the communication system also, in the telecommunication system, also our cellular communication system, we having the busiest hour is called traffic intensity. It is offered each user equal to the call request rate multiply the holding time. Okay, here we can find out like that the traffic intensity. The traffic intensity is a AU. The traffic intensity is a AU, and the holding time, that is a H. We can denote it with a H, and also call request. Each call request is a lambda. Lambda AU equal to lambda by H, and also for this we are having the some units. For this we are having the units. That units are erlongs. Okay, the erlongs are the units for traffic intensity. Okay, don't forget the units of the traffic intensity, that is a erlongs. AU equal to lambda H. The traffic intensity is offered each user equal to the call request, that is a lambda, and also holding time, that is a H. Okay, then we can find out the traffic intensity equal to lambda H. The units are erlong. Okay, like that we can see the next one, that is a total offered carried traffic. Okay, the AU is the each user intensity, each user traffic intensity. Okay, coming to A is the total traffic intensity, that is a U equal to A equal to U into AU. That means total number of users into the each user traffic intensity, then that is total offered traffic intensity A. Okay, that U is the users. Here we can find out the A equal to U into AU. Okay, like that we can move on to the traffic intensity in each user, or otherwise total users of the traffic intensity. We can find out like this. Okay, coming to some of the definitions for the trunking and grade of service that related to this topic. First of all, we have to see the setup time. Okay, actually we learn the trunking and also grade of service. What is the trunking? It giving the some a large number of users in the small number of channels, and also grade of service is the measurement of the particular system. Okay, with the what is the busiest hour, like that we can find out the grade of service. It is also called GOS. GOS. Okay, coming to setup time, the time required to be allocated trunked radio channel to a request user, that is called setup time. Coming to blocked call which cannot be completed at time of request due to conjunction, it is also referred last call. For example, we already seen in the previous slide. What is that? For example, here we are having the channel 1, channel 2, channel 3 and channel 4. Okay, all 4 channels are busy or occupied. Okay, occupied already, but fifth one person trying to call here, then what will happen? This is a blocked call. This one is a blocked call because the call cannot completed. We are lost the particular service. Okay, that is called blocked call. Okay, this is a setup time and also blocked call. Coming to one more definition is the holding time. The average duration of a typical call is called holding time. Average duration means how you say the average duration in the typical call means, for example, I consider in the morning 6 to 12, morning 6 a.m. to 12 p.m. Okay, for example, here the call traffic intensity. Okay, here we can see the traffic intensity in the particular hour. For example, this is at 10 a.m. In the particular hour, how many calls per hour? We can take the average duration. For example, the first person in the taking the 30 minutes, second person taking the 60 minutes, third person 10 minutes, the call duration. Then we can take the average duration 30, 60 plus 10 by 3. Okay, that is 100 by 3. The average duration is 33. Okay, like that we can find out the holding time. Next, coming to traffic intensity, the measure of channel time utilization, which is the average channel occupancy measured in erlangs. That is the units for the traffic intensity. And also coming to load, the traffic intensity across the entire trunked radio system, it measured in erlangs. Okay, we can, what is the load? The traffic intensity across the entire radio system. Okay, whatever filling to the radio system, the particular calls, that we can call the load. Okay, coming to grade of service, a measure of conjunction which is applied specified the probability of a calling being blocked for erlang B, and also the probability of being delayed behind a certain amount of time erlang C. Okay, some researchers giving the erlang, some researchers giving the erlang B system and also erlang C system. Okay, some of the researchers they given the erlang B system and also erlang C system. They're based on that. Okay, here we can find out the GOS, that is a grade of service. We can find out the grade of service in the particular radio system. Okay, coming to here, we can find out the C channel trunk system. If the traffic is equally distributed among the channels, then the traffic intensity per is given as AC equal to U into AC AU by C. We know that what is the U? Number of users. U is the users. Okay. AU is the each user traffic intensity. Each user traffic intensity. And C is the channels. Okay, that means AC is the traffic intensity per channel. Okay, that is AC. Okay, like that we can find out the traffic intensity per channel. Here we can use the U into AU by C, that is the number of users and each user traffic, and also we can divide it by the total channels. Then we can find out the traffic intensity per channel. This is the one formula for the trunking and grade of service. Okay, once we'll see the one problem, and then you can understand the clear picture about the trunking, what is the grade of service, how we can find out the traffic, total traffic intensity, and also each user traffic intensity, and also number of users. Okay, for example, you can see here how many users can be supported for 0.5% blocking probability for the following number of trunked channels is a blocked calls clear system. For example, A is a 1 channel, B is a 5 channel, C is a 10 channel, D is a 20 channel, E is a 100 channel. Okay, like that we can assume the trunked channels. The following trunked channels, the given A5, B5, C10, D20 and E100. Assume each user 0.1 Erlang of traffic. That means they given the AU, that is a 0.1 Erlangs, the given data. The given data uh, from the problem, we can see the AU equal to 0.1 Erlangs. Okay, and then what are the trunked channels? A equal to 1, B equal to 5, C equal to 10, and D equal to 20, E equal to 100. Okay, the blocking probability GOS is the 0.5%. Then we can write 0.05. Okay, 0.5%. That is a grade of service. That is a blocked probability. They given in the question. Okay, coming to before that, we have to see the Erlang B system for the grade of service. Okay, then you can understand the A value. Then you can find out the A value. Actually, what they are asking the question, how many users can be supported for 0.5 blocking probability? Then what is the formula? Actually, we know that A equal to U by U into AU. Okay, in the previous problem we've taken. Then U equal to A by AU. Okay, we have the formula. Okay, actually this is the total traffic intensity. Total traffic intensity. Okay, the total traffic intensity A equal to U into AU. Then we can find out the U equal to A by AU. AU is the each user traffic intensity. Okay, that is each user traffic intensity. This is a total traffic intensity. They given in the question. You can observe clearly what they are asking. How many users can be supported for 0.5% blocking probability? 0.5% blocking probability. Okay, that is a total trunked channels are 1, 5, 10, 20, 100, and also they given in the assuming for the each user generates, that is a 0.1 Erlangs. Okay, then before that we can see the what is the Erlang B table, how we can find out the maximum traffic intensity. You can see these are the channels S 1, 2, 3, 4, 5, 6 up to 20. Here the given clear picture, and what they given in the question, what is the percentage they mention? 0.5 percentage. Then we can see the what is a 0.1 percentage. Then we can assume this one. Okay, the first one is the C equal to 1. What is the A value? A value, what is the A value? 0.0050. Then in the given question, B equal to 5, C equal to 5, then A equal to, you can see this is a 1.132. Next, you can see C equal to 10. Then what is a A? C equal to 10, what is A? 3.960. And next, like that, the 20. C equal to 20. Then A equal to 11.09. Like that, C equal to 100. Okay, you can see in the next one 80.91. A equal to 80.91. Okay, like this we can find out the A value from the Erlang B traffic table. This Erlang B traffic table also I can provide into the examination point of view. Okay, from that only, this is one researcher giving the Erlang B table and also Erlang C table. Okay, from in that we can find out the what is a from particular corresponding the channels. C equal to 1, then we can go with the 0.05, and 5 is the 1.32, and 10 equal to 3.960, and 20 is 11.09. Like that, 100 equal to 80.91. Okay, like that we can, whatever the given in the question, what is the given in the question, what is the probability, we can see. If they given in the question 0.5 blocking probability, here they given the 0.1 blocking probability. If they ask 1% means we can go with the 1%, 2%. The based on the question we can giving the this particular traffic intensity. Then we are move on to the problem. We can see first they given in the A equal to 1. Okay, what is the formula actually? What is the formula? U equal to A by AU. That is a users equal to A by AU. Then whenever we are find out the A value from the Erlang B table, what is that? 0.0050. 0050. And also they are given in the question A equal to 0.1 Erlangs. Then you can substitute the for A equal to 0050 by 0.1. Then we can write approximately we can write 0.05. Then we can write one user. Okay, like that we can find out this is a one user. This is for A. Coming to B, they given a C equal to 5, A equal to how much from the Erlang B table? 1.132. Here we can write 1.132. Then AU is same 0.1 Erlangs. Then you can substitute U equal to A by AU. What is A? 1.132 by 0.1 Erlangs. Then we can write here 1. We can write 11 users approximately. We can write the 11 users. Like that we can find out the C. Like that we can find out the D and also E. Okay, coming to C also we can see here C equal to 10, then AU equal to the given in the problem 0.1 Erlangs. Okay, then the A equal to 3.96, then U equal to A by AU. Then we can write what is A? 3.96 by 0.1 Erlangs. Okay, then what is the number of users? U equal to approximately 39 users. We can write like that. Coming to D, C equal to 20, AU equal to 0.1 Erlangs. Okay, A equal to 11.10. Okay, then we can substitute the number of users. U equal to A by AU, that is a 11.10 by 0.1 Erlangs. We can write 110 users approximately. Okay, coming to E, C equal to 100, AU equal to 0.1 Erlangs, and A equal to 80 point something, 80.9. Then we can find out U equal to A by AU, that is a 80.9 by 0.1. Then we can write approximately 809 users. Okay, you can see clearly what is the question they given in the problem. How many users you can be supported for 0.5% blocking probability? They are asking the what are the truncode calls for the following clear system: C equal A1, B5, C10, and D20, E100. Assuming the each user generates 0.1 Erlangs. Okay, the 0.1 Erlangs is a AU, that is a each user can generate. That is a 0.1. They are asking in the question what are the how many users can support. That means U equal to A by AU. Actually, in the previous slide, we know it. What is the A? What is the total traffic intensity? A equal to U into AU. Then we can write U equal to A by AU. That is a total number of users equal to a total traffic intensity by each traffic intensity. Then we can find out the number of users. The based on the this Erlang B traffic table, we can find out the what is the blocking probability of the particular the given in the separated question. Okay, then we can write this one from the Erlang B table. Okay, then we can write, then we substitute the all the values. Then A equal to 1, and A equal to what is this is from a table, and this one is this one is from the problem. U equal to A by AU, that is we can substitute the A value and also AU value. Like that, B Okay, like that C and D we can find out. Then we can write the all the number of users. Coming to next one, here also you can see the another problem. Here the urban area has a population of 2 million residents. Okay, for example, you can consider Hyderabad. There we having the 2 million residents. Okay, the three competing trunked mobile network, system A, system B, system C. Okay, what are the mobile networks? For example, nowadays we are having the Geo one system and Idea and Airtel. Like that, you can consider three mobile networks. Okay, in a particular urban area. Okay, then you can see provide cellular service in this area. The system has a 394 cells with 19 channels each. Okay, system A having the 394 cells and it gives the 19 channels each. Okay, coming to system B, 98 cells with 57 channels. Okay, and also system C, 49 cells with 100 channels. Okay, they given in the data for the this problem. Okay, coming to what we have to find out. Find the number of users can be supported 2% blocking probability for each user, 2 calls per hour at an average call duration of 3 minutes. Okay, they mention here. And assuming that all three trunked systems are operated at maximum capacity, compute the percentage market penetration of each cellular provider. Okay, actually what they given in the question, system A. Okay, system A, what is that? 394 cells into 19 channels. Okay, system B, 98 cells, 57 channels. System C having the 49 cells into 100 channels. Okay, they given the question. And also they're asking the blocking probability GOS is the 2%. Okay, and also average duration. Okay, we can find out the average duration. Okay, average duration is the 2 calls per hour in the 3 minutes. Okay, we can find out the this one also. In the we can observe in the previous question they given the AU value they given in the question, but here we have to find out the AU. What is the AU? Each traffic intensity equal to AU equal to lambda h. Okay, this is a average call hours. This is a average call duration. Average calls per hour. This is a average call duration. From like that we can find out in this problem. Then we can combine the all the three operated system capacity. This is a problem. You can observe clearly. You 2 times you can read this problem. Then you can understand the clear picture about this problem. Then you can see here. First of all, we have to find out for the system A. System A, how many? 394 cells and 19 channels. 394 cells, 19 channels. Okay, and also we have to first of all we have to find out the AU value. What is the AU? Lambda h. Here they given the 2 hours per 2 hours per call duration, and also average duration is the 3 minutes. Then we can write 2 into 3 into 60. Okay, then we can write the 0.1 erlangs. Okay, we can write 0.1 erlangs because this we can write with the seconds and also hours. We can write that is a 0.1 erlangs. Then we can write the number of users U equal to A by AU. Okay, we know the AU value, that is a 0.1. And what is a A? Okay, that is we can find out from the particular graph. Then we can go with the 2% blocking probability. There we given the 57. First one is how many channels? 19 channels. Okay, you can write this is a 12.33. You can write 12.33 like that. We can find out. Okay, then I can write here 12. Okay, 12 by this 0.1 erlangs. Then we can having the 120. Okay, that is a number of users are the 120 users. Approximately I am writing here 120 users. Then we can write 394 cells. Okay, we can write for system A. System A 394 into 120 users, 394 cells into 120 users. There we can write 47280. Total users are the, for system A, 47280. This is the system A. Okay, like that system B also we can find out. System B, what is the system B? How many channels? How many cells? 98 cells, 57 channels. 98 cells, 57 channels. Okay, the AU is fixed, that is for 3 networks, 0.1 airlines. Then you can write U equal to 0.1. AU, we know it. What is a A? We are taken from the airline B table. Then we can write 450. We can write 450 users. Then we can write total 98 channels, 98 into 450. Then we can write 44100 users, 44,100 users. This is for system B. Okay, don't confuse. Okay, they given in the question clearly what are the cells, what are the channels. Okay, then how we can find out the each user traffic intensity, that is a AU equal to lambda h. U equal to, what we know the formula in the previous problem also we done. AU equal to A by AU. Then we can substitute. This is from Erlang B system. This is for Erlang B system. Okay, we can find out the A value from the Erlang B system. Then we substitute the values. Then we can get the 120 users. Then system A equal to 394 into 120 users, because we can multiply with the total number of cells into number of users. Then we get the 47,280 users. Coming to system B also same. We can find out the 44,100 users. Like that we can see for the system C also. System C, how many channels and how many? 49 cells and 100 channels. 49 cells, 100 channels. Okay, for system C, 100 channels. Then we can find out the U equal to A by AU. We know it. We already find out the AU value, that is a 0.1 airlines. Then we can substitute the U equal to. We can find out this from the Erlang B table. This is from Erlang B table. Okay, then we get the 88 by 0.1 Erlangs. Then we get the 880 users. Then we have the 49 cells. Then we can write for system C equal to 49 into 880 users. Then we get the 43,120 users. Then we get the 43,120 users. Okay, and also find out the they asked in the question for a system A, system B, and system C, how many users. Okay, like that we can find out here. What is the first system A? 47,280 plus system B. System B, what is that? 44,100. 44,100 plus for system C 43,100 users. Then we can write out how many users. Okay, here we can write 1,34,500 users. The total users for the system A and system B and system C total operated. Okay, you can see first of all what is asked in the question. Okay, they are assuming the all three trunk system operated the maximum capacity. Okay, that is the total maximum capacity of the 3 trunk system. Okay, first of all they are asked 2 million population in the one urban area. They giving the service area of the system A, system B, and system C. The system A having the how many channels and how many cells. Okay, system C also, so how many channels, how many cells, and system C also same thing. Okay, they given in the question each user call per hour is 2 calls per hour at an average call duration of 3 minutes. Okay, then we can find out the AU lambda h. This is the average call per hours. This is in the average call duration 360. 3 by 60. Like that, we can find out the point. Okay, this is for the average call duration, and also we can find out the what are the measurements for this one. We find out. Okay, this is clear for system A, system B, and system C. Okay, what we have done in this session means we find out what is the definition of trunking, what is the definition of grade of service, and also what is the traffic intensity of each user, what is the traffic intensity of total number of users, and also we can find out the what is how many users supported for the trunk system. That is a U equal to A by AU. Okay, in the next session we also discuss how we can improve the cellular capacity with the cell splitting or sectoring or any other frequency use. Okay, that we'll see in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.